Hello everyone, today let's go over another medium question that I solved by myself today. This one is called shortest unsorted continuous subarray. So essentially you're given an integer array of elements and you want to find one subarray, subarrays are always contiguous, that makes the original array completely sorted in ascending order when you remove that subarray. And we want to find the shortest causing subarray if that exists. So for example, here you can see that that would be 6, 4, 8, 10, 9, because if you remove this section, you get 215, which is sorted in continuous order, in ascending order. And then if you don't find, or if the input is already sorted in ascending order, then you can just return 0 because there's no length, right? That's required to make the array sorted because we want to find the shortest length. Okay, so yeah, so the easiest way to do this, I think, is to compare the original array. So let's print nums. And then let's call this sorted nums. So we're going to store a sorted version without overriding the original input. And we're going to print it. As you can see, this is the sorted version, what we want. This is what we were given. So now what we can do is simply iterate through the original array we were given and compare it to the correct answer. So if the element is not equal to the correct answer, which means, for example, the 6 is not in the correct position, it's supposed to be at 4. If it's completely sorted, then we can add it to this other array. We can append the current index to say that, hey, this is a problematic child, right? And then let's print this other array. As you can see, index 1, 4, index 1, 2, 0, 1, 2, and 4, 5 are misplaced. So cool. So now that we have this, let's also define another variable called misplaced count. And every time we find a misplacement, we have to increment that. Oops. So, okay, so now that we have our misplaced count, now we can simply iterate over through our array. And if we come across one of these arrays, then we can increment the total because we know that we're looking for something that makes the array completely sorted, right? So, for example, even though our misplaced count is only 4, the answer is 5 because although 8 is placed in the correct position, we still have bad children later that have to be recognized. So now we can just iterate over our array with the bad indices. And then we can simply say, or we can iterate over, iterate over the original array. And then if I is in this, it's a problematic index, then we can increment the result. And then we can also say that, yeah, so if I is in other, increment result. On the other hand, if I is, so if it's not in other, but we still have totals to go. So for let's decrement misplaced count because we're seeing it, so we're correcting it. So if misplaced count is bigger than 0, then we can also increment result, right? I want to decrement that, and let's return this to C. Okay, so, okay. Or I in other. Let's see here. Okay, so, okay. You know what? That's actually not necessary because what we can do, since we already have the answer here, right? So we can simply say that well, in certain cases, other is not going to exist. So if not other, which means that the other array has no elements, then we can just return 0 because the input array is already sorted, right? If that's not the case, then we can just return, because we know this other array is already in sorted order because we're going from left to right in the input, and it's keeping track of indices, right? So we can just say current or other of -1 minus other of 0, and then +1 because we want the length, right? And as you can see, it passes all test cases. And yep, I hope this is helpful and intuitive. And stay tuned for more. Thank you for watching.